So let us see on how we can be able to find the position vector as well as the Gromit vector for the vectors in a three-dimensional coordinate system. Let's say we have a three-dimensional coordinate system, and I would say, let's say this is the z-axis, and let's say this is, that should be x-axis, and this is, let's say, y-axis. Let's say this is the case. Now let's have an interest to have, let's say, a point A within the three-dimensional coordinate system. Let's say this is the line drawn from the origin to actually a point A, and we should have to express this as a vector. Now, assuming that this is the origin, I should say this is the origin, and which is given as O. Now, the line OA can be expressed in terms of the vector, or have it as vector OA. Now, this is what we call the position vector, because it is the vector from the origin of the three-dimensional coordinate system. That is the position vector. It is the vector actually drawn, or it is the vector whose tail is drawn from the actual origin. But for instance, let's think of having, let's say, a point, I should say point B within the three-dimensional coordinate system. And let's say this is, I'll have it as a point C. That should be that. And let's think of connecting the 2 points with a straight line. Then what you're having now is the line BC. But let's think of expressing the line in terms of a vector. Now we may think of having the line or the vector in this direction. Now what we have, it's a vector BC. So this is the vector BC, and this one is said to be the Gromit vector. It is the vector from one point other than the origin within the three-dimensional coordinate system to some point within the three-dimensional coordinate system. Now this is what we call the Gromit vector, and this is what we call the position vector. So position vector, it is the vector from the origin, and the Gromit vector, it is the vector within, it is the vector originated within the it is the vector originated within from one point to the another point within the three-dimensional coordinate system other than the origin itself. Let's say we have actually a point A with coordinates 2, 2, let's say, 5. And we have another point, let's say a point B with coordinates -1, 0, let's say 2. And we should have another point, let's say point C with coordinates, I have it as -5, 4, let's say 3. Now, what is the vector OA if this is the case? So this is the position vector of actually position vector of a point A, where O represents the origin. You should have to understand that as it stands here, it is the same as now. In terms of the vector, we are going to express the position vector OA in a component form, where we'll be having it as, I should say, the coordinates of I'd say the point A minus the coordinates of a point O, of which what are the coordinates at the point A? Now we'll have it as 2, 2, and 5. We'll have that. And minus what are the coordinates at the point O, which is the origin? We have it as 0, 0, 0. That is the origin. Whose coordinates are given as 0, 0. So in this case, we'll have it as 2 minus 0, 2 minus 0, and also 5 minus 0. We'll have that. So in this case, the vector OA will be given as 2, 2, and 5. As you can see on the position vector, the vector OA is presented by just expressing the coordinates of the point A in terms of the vector. So this is how we should have to understand about the position vectors. And let's think of also having the vector, I would say OB. So what is the vector OB? Now this is also the typical position vector. So the vector OB will be given as the B minus actually O, where O is the origin as it stands. Now in this case, we're going to express the coordinates of the point B in terms of the vector in a component form, or have it as, -1, 0, and I'll have 2, and the minus. This is a must. Actually, whenever we are expressing the vectors in a component form, we should have to use this, what we call angle brackets. Keep that. So have it as a minus. Now we'll have 0, 0, 0. In this case, we'll have it as, we're going to subtract the component from -1, I should say minus 0, and 0 minus 0, and the 2 minus 0. So we'll have that. So in this case, we'll have it as -1, 0, let's say 2. So this is the position of vector actually OB. So keep that in mind. So in this case, what I've seen and what you can observe is that what you should have to observe is that, let's say we have a vector OC. So in this case, the vector OC is just the same as -5, 4, 3. Only that we should have to express this in a component form using what we call the angle brackets. Now this is just that, or even the vector OA, instead of going over all those processes, you just have to express the components of the vector A in terms of the vector, I should say the coordinates of the vector A in terms of the component form of the vector, and that will be given as 2, 5. And this is only happens whenever we are dealing with the position vectors, the vectors that are originated from the origin to either point. Even let's say if we have a point M with coordinates 5, 5, let's say 2. Now what is the position vector of a vector M? So in this case, this is just the same as 5, 5, and 2 in a component form, representing that it is a vector case. So keep that in mind. Now, there's something you have to understand as well. We know that, let's say, a unit vector, we know that the position vector OC can just be given as -5, 4, 3. Of course, that is the case. Now, what if we are aiming at having, let's say, vector CO? What would you say? So try to have what can be the vector actually a CO, and what can be the vector, let's say, BO, and what can be the vector, let's say AO. I want to see the responses down in the comment section below. Now, what is the Coulomb vector? So Coulomb vector, it is the vector originated from whichever the point within the actually a space to whichever the point within the space other than the origin. Let's say we have, this is a point A, this is a point B. I should say this is the point C, of course. Now, what is the Coulomb vector? Let's say a vector AB. So in this case, the principle remains the same. The coordinates of B minus the coordinates of A. Now, we are expressing this in terms of a vector, and that will correspond to have it as, what are the coordinates at the point B? We have -1, 0, 2. The minus, what are the coordinates at the point A? We have 2, 2, 5. We'll have that. Then we're going to subtract the componentry. That corresponds to have -1 and a minus 2, 0, minus 2, 2 minus 5. So in this case, we'll have a vector AB being given as now have -3, -2, let's say -3. So this is what we call the Coulomb vector AB. So always you should have to remember that the coordinates of a P should have to subtract those of acted A. Now we should have to express them in terms of the vector in a component form. So keep that in mind. Now about, let's say, if I wish to have, let's say, vector BC. Now principle remains the same, and the vector BC will be given as the coordinates at C minus the coordinates at B. Now being expressed in terms of the vector, or have in a component form, that is negative, I should say -5, 4, 3, and the minus. And how about that of 2, -1, 0, 2? In this case, we'll have -5 minus and -1, and that is 4 minus 0, and that is 3 minus 2. So we'll have that, try to complete that, and also try to have, let's say, vector CA. What is the vector CA? And let's say what is vector, how to say BA. What is the vector BA? And let's say what is a vector, I should say CB. So try to have those vectors in that way. So that's how you should have to understand about the Coulomb vector as well as the position vector. So Coulomb vector, it is the vector originated within the space. Mind you, the region within the three-dimensional coordinate system is said to be the space. So Coulomb vector, these are the vectors emanated from a point within the space to some point within the space. And the position vector, it is the vector originated from the origin to some point within the space. So that is how you should have to understand the Coulomb vector and also the position vector. Thank you.